Hi everyone, I'm Gurpreet from eBay, and we work in the identity service team at eBay in Seattle. So in this presentation, we'll go over the entity resolution service, and this service brings the identity world to online, and how we do that is covered in these slides. So during this presentation, we'll talk about a component known as XID a lot. XID is nothing but our internal representation of a customer, and how we developed XID, and then what prompted us to go to the online route, and everything we'll cover over this. So the problem statement. So eBay maintains hundreds and millions of accounts across various properties. By properties like marketplaces, PayPal, which is now a separate company, but we do have their accounts, and StubHub, and other identities that eBay has. Now these accounts are sometimes unstructured. Their specification is in unstructured format. They use different character sets, different sort of languages, and they change over time. Some people may change addresses over time. Some people have name change. So how do we identify in these changing properties, changing identities, that these people, these accounts belong to the same person? Once we have done that, once we have done that these accounts belong to the same customer, it helps us in various areas like fraud prevention. In this particular case, creates customer service or marketing, personalization, and all that. So first, what we did was we developed the batch components. This was a 3 years long journey. Very first thing, we developed XID, that is customer identifier, on the PII side. So that is your touch points, name, phone number, all those kind of information. If the person has agreed, then we collected that set, created the edges based upon certain rules, and we'll go over those rules, and created a graph out of it. Now once we had this graph, this was in batch mode, right? So we had few customers for this. The second component came, now what is this customer doing on their devices? And the devices can be your web browser or phone, Google Ad IDs, all those things. So how do you correlate the clickstream data? All this data is collected as part of clickstream and other interfaces. How do you correlate the customer XID information with the device activity, with the activity on web and various places? So that was another component that was developed. So we had a graph which correlated various type of device identifiers, or we call it any ID internally. That is any sort of touch point that we can have. Once we have an edge, we can correlate and create a graph out of it. Now once we had that, we have a complete set of information on our customer to enrich their experience, right? So let's say if you're browsing on a device and you're searching for something on eBay, now if you go from one device to the other device, we know we can personalize your experience in a better way. So once we did that, all this was done as part of batch processing. In batch processing, our technology stack was primarily Hadoop, MapReduce, Hive, Spark. We had Giraffe. We started with Giraffe initially to do connected components, but once the Yarn once our Hadoop environment got upgraded, Giraffe stopped working, so we went to MapReduce. And we dabbled with Spark graphics also. So the batch component, once it was done, but still we were not getting that traction from various teams, right? So everybody said that I wish if this was present online, if this was present as a service, if this customer information was present as a service, then we can call it directly using any sort of identifier and get the entire information about the customer and then use it in various ways. And this prompted us to go to the entity resolution service route. So you have the graph created using PII, various touchpoint information. You have another graph which correlates this touchpoint information, this PII information with the GUID activity. And then the ERS joins both of those and then gives you a comprehensive view of what a customer, basically, what a particular identifier is doing. So this is an overview. Like XID links user credentials and transient identities to recognize a customer, right? We have hundreds of millions of accounts, 20 plus different linking strategies. And by linking strategy, so we can have like phone number can be one linking strategy, first name, address, all those kinds. We call them buckets internally, so these are the type of edges that you have. So we use around 20 plus different linking strategies, billions of cookies and other fingerprints that are assimilated through various sources, and they're used for identifying, creating these graphs. And then we recognize customer across sessions, sites, browsers, devices, so any type. So idea here is that the framework should be so generic enough that we should be able to extend it to incorporate any sort of ID that we can get. So let's go to the next one. So a brief overview on the solution that I described. So various sources. Now the sources can be something like, if you see here, so if you see here, the sources can be like marketplace, input data set, PayPal, StubHub, or Be for Friends, and everything comes into one single area. We basically put them into a single normalized form. And similarly, we can have data set from other areas, put them in, create the buckets, create the edges out of them, then do transitive closure, create a graph. And then one of the big thing that we do is we want to know like how did a graph changed over time. So we create versions actually. So if the accounts associated to a customer change, suppose you decommission an account, or maybe we linked incorrectly a particular account, so we create versions on top of the accounts so that we can know at particular point in history, how did the graph look like. So edges, graph, and the final data set is in form of a simple table. So account and entity ID actually. So entity ID is nothing but a customer ID. So on a very high level, this is how the solution progresses. Okay. Maybe take.
So this is our architecture. We followed the Lambda architecture to design our scenario. The top line is a batch pipeline. So first block is XID entity resolution, as Gurpreet just explained. So it runs every day. It's a bunch of Hive jobs. Once the entity resolution is done, another set of Hive jobs kicks in, which is the second block. We dump the XID data into about 2,000 files in HDFS. Once the data dumping is done, a Spring Batch job will kick in and move all these 2,000 files over to a different network zone one by one and start processing the data. Insert all the data into the data store, which is a Couchbase store. So this is a batch layer. Bottom one is the near real-time process engine. We use Apache Storm and the Kafka queues. All the events comes into Kafka queue as different topics. Or in Storm, we have different bots to pull the data and process and save it in a separate data store. On the rightmost part is the entity resolution service. The service is a RESTful service. It's pulled the data from both store and based on some rules, merge all the data together and send back to the customer. We have the internal tool called Sherlock to monitor the whole process here. In this design, as I mentioned, we use Hive to do the major batch process. We use Spark, Storm, and Kafka to do the near real-time engine. We use Spring Batch to load the about 2 billion data into the Couchbase. So there's several things I'd like to highlight is we optimize the data model to be able to serve the data in the really fast mode, which is a 2 millisecond response time, where our customer is very picky on the response time. And right now we have about 10K concurrent per second concurrent request. The last thing I want to highlight is the Couchbase cluster. We have 3 data centers. Each data center has 17 nodes with 11 terabytes. This is one of the biggest Couchbase cluster probably in the world, according to Couchbase team.
So these are the actual slides where basically these are the problems, these are the issues, these were the reasons, these were the areas which impacted our design a lot. So we'll go over them one by one in the next coming slides. So till now, as you have seen, what we did was we developed a batch solution, XID with user identities. Then we created a GUID-based solution. We associated this user-based solution with this online activity graph. And then finally, what Ying went over the architecture, that architecture was for how did we brought this batch information onto the real world side, onto the services side. And in that, we had 2 phases. So the first phase was where we just processed the batch part and put it into a JSON file, and then we loaded it into Couchbase. So that was phase 1. So that was, you can say, only the batch and the speed layer of the Lambda architecture. Now, in the next phase that we are currently working on, we have incorporated Kafka. So basically, we are bringing this additional real-time information and processing it with a Couchbase, which is only for the NRT processing. The idea being that the transitive closure, the graph linking, the graph that we built based on the real-time data will not be based upon pure edges and everything. It will be a pretty simple graph. And the goal is that once the batch runs, nightly it will be updated with the correct version of the graph. But still the user will have their information very, very quickly in 2 milliseconds or so. So that's what we are working on in the current phase. Now these are the challenges that we faced when we were working with this ERS, when we were designing for ERS and all that. So raw clickstream plus PII data, and as I said, that this is a long journey that we took, right? So when we started with, we had our clickstream data is in itself in petabytes, and then we get this myriad, huge variety of sources, right? We have Hydra, Adobe's, and all those kind of different IDs, right? So the data set in volume itself was quite huge. And to filter it down step by step into meaningful graphs, that processing power, that's the processing, that processing we did using Hadoop and all that. And our Hadoop cluster is fairly large. It's 2,500 nodes on which we process the data set. And many times we run into this scenario where we spawn more than 80,000 and 90,000 mappers. So it's, yeah, at Hadoop at large scales, it poses different sort of problems, right? So, and that was one of the reasons, actually, when we were working on this, we had this, I had to make this decision whether I go with reliability or I go with something which is quite new. Like, I wanted to go with Spark, but then I realized that with the amount of queue capacity that our team had and other things, actually the current jobs that were already running, I think the best solution to go with is Hive, since in batch mode, right? So our SLA is 1 day actually to get this data across. So yeah, raw clicks in data plus PI and petabytes. So this is how it impacted our decision making. Now 20 plus edge type, as the edge types are the buckets actually. So how do we classify this data? How do we group this data into different type of edges and then join them? So interesting story here. So when eBay and PayPal were separating, at that time you only had the XID1 solution, and at that time we were processing around 20 billion edges or so per day, and something happened in downstream, and slowly our job started failing, and it didn't run. Basically, it's going slow, and it stopped working. And we had introduced some change at that time, and we thought that it's because of that change. So it was an innocuous change or so, file format change. But then slowly, suddenly, we realized that there was, during this migration process, we introduced a space or something in the keys, and that led to our edges multiplying many folds. So the edge list went to 330 billion or so, and when we were basically when we could handle only 20 billion or so. And that was the reason it went down. So the job stopped working. So now with further enhancements, basically our Hadoop cluster has also grown and all that. So now we are at 100 plus billion edges, and it's fairly stable. The job is, it's been working for 2-3 years now. It's fairly good. So, but they run as two different. So to give you an overview, we have 3 batch processes that run. One is for the XID customer identifier. One is for XID online, which groups all the online touch points together. And the third one, once these two complete, it's the ERS one. So entity resolution service, where we create a comprehensive JSON which has all the information for the customer that's required. Now, from the complexity perspective, if you see, we have 2 huge graphs, and we have to join them together. So it adds its complex operation by itself, and then comes in the additional requirements from the product side, where they bring in the temporal aspect of the identities. That means if we have to present 20 identities, 20 components, I'll say 20 goods linked to a particular account. Let's say Gurpreet Singh is linked to these particular devices. Now, what the requirement here is to create I'll go into the details, to create an array which is sorted based upon the reverse time. So most recent time, most recent GUID comes in the front. Now this creates additional complexity where we not only have to have the graph, but we need to have the information about when this GUID was last seen also. So that helps the end customers because now they don't have to worry about, they can just pick up the first one and use it. So it enhances the personalization and all those processes actually. Process is complex, so we have long-running processes which sometimes run for 8 to 10 hours. You have three different processes which are very huge actually, and in all they spawn more than around 200,000 mappers or so when they run actually. So there's complexity on that component. Geo-redundancy, so there's a very interesting story behind this. So when we started, so the first approach was what is the best approach, like what should we do? So we did some POC. So Ying was working on the Couchbase side, Couchbase POC, which we finally adopted. I liked Elasticsearch, so we tried with Elasticsearch, and the numbers between Couchbase and Elasticsearch were equivalent at that time, but geo-redundancy option was not there with Elasticsearch, at least in our environment. So that was a no-no because we need to have that component. Now, geo-redundancy, we use XDCR, right? XDCR for Couchbase to get geo-redundancy, and that has its own issues sometimes, right? So it gives us a long tail. Maybe you can speak to it. The XDCR long tails and all that. So primarily what happens is it takes time when you are replicating between two, three different geo-redundant clusters. It takes time for it to stabilize actually. So at this particular level, yeah, that's one of the things that we have observed, that when we are loading the data set, it takes, most of the data set loads very quickly, and then there is a long tail actually after that. Now the requirements, requirements are the biggest complexity. So for a developer or for an architect actually, from the product side, they'll keep getting new requirements that you have the time included, now we want to see when these edges were created actually. So the problem is, from our perspective, if you have to satisfy the 2 millisecond response time, you have to go with key value store, right? And if you have to go with key value store, one of the major aspect there are two variables that gives you the speed. One is the document size, and the other one is the number of keys that you have, the number of keys that you have to store. So that corresponds to the active resident ratio in Couchbase, right? So you need to have everything present in memory. If you want to see everything quickly, you have to give this sort of response time. And the problem here is if you increase the size of the JSON, you evict certain keys from the mem side. So yeah, so when we started, our mem size, our average document size was around 3 kilobytes, 3K, and we had around 2 billion keys. And now the problem that we ran into was that this configuration didn't give us 100% active resident ratio. So not 100% of the keys were there in the memory, right? So how do we, what shall we do to ensure that the data set is present in mem? So one of the things that we did one of the levers that we turned was, the only lever that we could have turned was the document size. And in order to do that, we went ahead with creating a referential document type. So we'll have a primary document, which will contain the entire information, entire body. All others which refer to the same graph will just point to it. We'll have a reference key which will point to the primary document. Now this helped us to get the document size to half, around 1500 bytes. And surely it helped us to bump up our active resident ratio. So our active resident ratio went till around 85% or so after this change, which was pretty good. So yeah, that's on the requirement side. So products will keep giving the requirements, but from on our side, yeah, we have to make a decision on how do we keep our response time and everything, and satisfy the requirements also. So requirements were a difficult part. The other thing, and I'm pretty sure that everybody has run into this. So any project, even in big data world, that you get is everybody's waiting. So implement it right now. We want it right now, right? What you have to, you just have to write few queries, right, to get it done or something like that. The problem is once you start running even a simple query, a simple aggregate, it may take a lot of time to actually finish if it's 1 petabyte of data, right? So that's a challenge. Infrastructure is a challenge. Infrastructure, so as we pointed out, so the Couchbase cluster that we have is around 17 nodes right now. It's one of the bigger ones in the world, actually. And in order to have that amount of mem and that amount of hardware present, actually it took us some time to get the infrastructure ready, actually, too. So it was good that we got it at the nick of time, but so you have to develop in parallel. So basically, start developing in the POC environment and then just move on to the infrastructure once the infrastructure is ready. And as I said, deliver it ASAP. Everybody would like to see the solution working ASAP. And one of the things that we saw was, so when we, just an anecdote here, so when we first loaded the data set, and then for a few days, we didn't realize that we have a function, a property known as time to live counter on every record. Right, so time to live was 14 days, and initially when we loaded the first batch set, we were doing some post-production, post-rollout verification before releasing it to customer. And then all the records, actually, the TTL expired on almost on the same time, and that brought the Couchbase cluster down. So that was another thing that we learned from this, that we have to stagger it in such a way. The other thing that we are seeing is that when you have the batch load going on, and at the same time you have the service access. So batch load impacts the service access time. So response time is negatively impacted. Now, how do you stagger that? That's a problem that we need to work on. The other problem that we saw was you can have a particular identifier associated with maybe 500 customers, let's say. If it's a library, if we go it on the library computer, right? Then that slows down the entire response, the average response time for the others also, right? So if you have a call which is taking, let's say, 10 seconds to respond, that will, in this particular scale, it can slow down for other customers also. So skill set is something that we, so we dabble with all the time, right? So the technology is changing so quickly, so you bring up your team working well on Hadoop and everything, and then you realize that now you have to move to the NoSQL world, actually. So you have to acquire the NoSQL knowledge and at the same time do the implementation. So all of us went through trainings and all that. Near real-time processing, this is an interesting area that we are working on right now. Ying, you would like to speak on the near real-time side?
We are working on that.
Right. So NRT primarily Kafka and all that. So Kafka, Storm, and all that. And so you have to acquire knowledge as well as deliver on a restricted time frame. So one good thing from the eBay perspective is we have frameworks that are already developed, actually, that help us to move quickly. And from future growth perspective, more business use cases. So you have 10 different types of identifiers already integrated. You want 5 more, 10 more to be there. So they're never-ending business use cases that are always there. Then data volume is continuously increasing. So yeah, so this is an area where we have to, when we do the estimation, sizing estimation today, we have to look into account on how does the data volume change, what's the history and all that. Data variability, so this is another challenge actually. So different type of GUIDs, different type of accounts, different languages and all that, how do you bring everything together? So how do you increase the quality of the graph and all that, even with this variable data set that you have? And data velocity, of course. So with real-time and batch integration, you suddenly have a real-time pipeline where you need to ensure that it should merge with the batch layer and give meaningful information to the customer. So let's say the challenge that we've that you run into is right now if batch is even though 1 or 2 days delayed, but once you integrate the real-time pipeline, how do you make sure that the batch catches up with it the next day? So you have to think on those lines also. So now key takeaways that we had were, so optimize the Couchbase data load to prevent negative service impact. So how do you stagger the data load and all that so that your service impact is not there? Then reduce the JSON size to increase the active resident ratio, so the caching ratio. Geo redundancy by data replication, so the XDCR, Couchbase comes with XDCR and it works good, so we need to do that. And finally, enterprise big data solutions are complex and they take time to so design process from our perspective is very important. So when you are at design phase, it's better to spend a bit of more time and think about all the variations that will occur. And then once you are in development, look for any issues. So one aspect is these things, even if you develop on your laptop, they'll work perfectly well, but once you put into the production mode, the entire cluster mode, you will see the actual issues that happen. So the delivery should be continuous sort of actually. So you do develop part of it and see how it runs with actual data set. So you see the issues potential issues that you can get and all that. So that's pretty much it. So any questions?
So was there a specific reason that you went with the document model in Couchbase? And where is this document actually being generated when you're getting data out of Hadoop?
Yeah. So this document, so one of the reasons was, and probably, so this document gets generated as an output of Hadoop processing, the entity resolution service batch processing. It's a JSON document. And so
the question is why we generate the document, right? Yeah. So our design is we want to optimize for read. So we want to get and get everything and pass to the caller. So it works perfectly if we just pass in one ID and we model everything we need to return inside inside of this query as a key and pass it over to the caller. That's just one get. That's our goal. So that's why we model this. We somehow duplicate all the content in one document.
How does client know what is the time?
From their perspective, it's the usual. Suppose somebody logs in, right? So at that time they have the information. So what account it is, right? So they can query by your account and see, okay, if they have to personalize the experience that you want to have, they can pass in that account information and they can get all the information associated to that particular account.
The client will get everything about this ID and they can filter from the service. I just want some specific ID. They can filter out other IDs to cut down everything else. So by default, we give everything out.
Yeah. Yeah.
You talk about entity resolution, so can you tell a little bit about the algorithm? Which algorithm are you using, and how is the performance?
Can you repeat the question?
So which algorithm are you using for the entity resolution? You mean to say the graph, to prepare the graph actually?
Yeah, sure. Yeah.
Right? So on that side, it's not us. It's basically another component. It's another team member who does that. But it's the standard connected component library that graphics or anything has. So you create an edge, right? And then you just link those edges together and create the graph. Was that your question, or? Yeah, we can talk separately. Yeah.
So you said you use Spring Batch to load data
Yeah.
to Couchbase.
Yeah.
So why Spring Batch?
Uh,
And what other alternatives did you have?
At that moment, the Spring Batch is pretty much our only choice. But we try to think about, for example, we use another service to send insert the document one by one, but it's too slow. Spring Batch gives us much better performance, throughput. Yeah.
How does Spring Batch does not integrate with HDFS, like why?
Right, right. The Spring Batch is actually a list of tasks. The first task is to move the data. Remember, there are 2,000 files. We move the file over to the local storage. That's the first step. Then start the batch load to the Couchbase. We have about 81 machines running on the same fleet. So it's run the same job. So one of these will start move one data file over and load the data. Then if there's other files left over, it keep moving until everything's done.
So basically the orchestration, so using Spring Batch for some sort of orchestration?
That's
like
correct.
pipelining, like
That's correct. We have a control kind of metadata in our Couchbase. It's a big chunk. Each time the 2,000 file is a big chunk. We have a control metadata in the Couchbase. We write down which file has been moved. So in the control bucket, so we know where we are. It's a unit of work. So we have to make sure today's load is done before we start the next day.
right. Could you have done it in Spark or no?
At that moment, we didn't try Spark.
No.
Spark,
Probably will come next. As part of another initiative, we are building a very strong Spark cluster. And right now, the batch component is in Hive, and Hive and MapReduce primarily. And there are some components which are in Spark, but that belong to the other.
Also, in our company, we have different network zones. So Spark may not work in our environment, but definitely we should think about it. Thank you.
So the Hive batch processing you're mentioning, is that the one which is generating that JSON?
Yeah. So yeah, as I said that I had to make a choice actually between whether I should go with Spark or Hive in that particular environment, which was highly congested. So I decided to go with Hive because of the reliability thing. I knew that from the experience in that environment that it does complete actually within the time frame that we want. And yeah, so on that side, actually, as part of the initial verification, so we try to verify as much as possible, basically that the association that's created between two edges are correct. So that was, we took the random samples and verified that everything is actually linked. Then the other thing that we did was, once we had the solution done, we created an analysis tool on top of it. So it works in a reverse fashion. So let's say you give us an account and you want to figure out why basically, tell me the graph of this account and why why that information is linked actually. So what it does is it will go and basically do a reverse tracking through the entire buckets, transitive closure and everything. And it will give you a picture basically we used Neo4j to do that. It will give you a picture in Neo4j that this is the graph for this particular account with everything associated. And these are the PII, this is the PII or other sort of information associated to this person. And this is the reason why it's linked. And it was linked in these buckets actually. So that helps us to do that. Yeah, definitely. So since this is in production, so initially when we launched, we got lots and lots of queries like that, and that was one of the reasons that prompted us to do that.
So because you have PII, and that's in the document, in the graph, right?
So what happens is PII information resides in separate tables and all that.
Okay.
So that graph only has the edges actually, only the edges. So in order to actually generate this analysis information, you have to go back and link those edges back to the PII and tell them that, okay, this is the reason why it was.
So do you have a requirement because of GDPR and all to mask PII?
Yeah, definitely. Yeah. So PII actually is totally encrypted. It's encrypted actually. So it gets only for certain scenarios actually, only for when required. And then it depends upon customers also, if they want to actually give us permission to use the PII or not. So in many cases, the data is PII removed also, so from privacy perspective. So all that is taken care.